Here we're going to talk about weird solutions you might get. What interesting solutions might you get when you solve an equation? So let's start by remembering the solution to an equation is the value of the variable that makes the equation true. The solution is the value of the variable that makes the equation true. Okay, so far, what we've seen is one solution. Like this. I have x plus 7 equals 10. And you think, what value of x makes that true? What number plus 7 equals 10? And maybe you're just looking at that and just thinking to yourself, oh, well, 3 plus 7 equals 10. Or maybe you're more comfortable using inverse operations. Either way, the solution is x equals 3. And there's just that one answer, that one solution. Okay, so everything we've done so far has one solution, right? Like, again, even if I have multiplication, what number times 4 equals 20, right? You could do this. But there's just the one answer. So if I were to say, okay, well, what's the solution to this equation? You'd say, well, x equals 3. Or x equals 5. Okay, but there's these other possibilities. One possibility is that there is no solution. That there's no solution to the equation. There's nothing, no variable that would make it true. Here's an example. Can you think of a number that if I take the number, let's say 3, that it's equal to that same number plus 1? Like, let's see, 3 equals 4. Is that true? No. Let's see. 7 equals 7 plus 1, 8. 7 equals 8. Is that true? No. Okay, what about a negative number? Negative 10 equals 9. Negative 9? No. Right? So the thing is this is never true. There's nothing you could input for x, right? You could try 0. Still no. Right? This has no solution. So if I said, okay, so you can look at it and see that there's no solution, but I want to show you, like, here's the format that you can always figure out if it has no solution. Here I have variables on both sides, right? So this is actually like, remember when we see variables on both sides, we say, ooh, we can't have variables on both sides, and we subtract. So like, I'm gonna subtract x from this side. I'm subtracting 1x here, subtracting 1x here, and what I actually get here is 0 equals 1. And you can look at that and be like, that's not true. That's never true. It's never true that 0 is equal to 1. Okay, so now I know that this equation has no solution because there's no value of x that's going to all of a sudden magically make 0 equal to 1. Okay, let's show you another one that's longer, but it's the same idea. Okay, look at all this. Whew. Okay, on the left side I have to distribute. So 3 times x is 3x, 3 times 4 is 12. Over here, 5x minus 2x, I'm combining like terms, is 3x. And then this is 12 minus 1 is 11. And I think, oh, I have variables on both sides. Let me subtract, let me get rid of this 3x over here. Oh, that's weird. There's 3x over here too. So look what happens. 12 equals 11. Nope, that's not true. 12 does not equal 11. This is no solution. Okay. I want to just point out one thing real quick, a point of confusion. If I have something like 3x equals x, you might think like, oh, that's kind of like this. It's not kind of like this because look, if I say, let's just like solve this out, right? And you might be able to look at this and think of a number that this is true, that if I take a number and I multiply it by 3, it's the same as the number. Maybe I'll just pause for a second and think of a number that makes that true. But the other thing I can do is I can say, okay, well, this is 1x. I'm going to subtract 1x from both sides. And I get 2x equals 0, and then, right, I could actually just formally solve it, and x equals 0 here. So that equation has one solution, right? Because I can multiply 0, and I end up with 0. So that's like 0 has like the special property. But here there's no number that I can add 1 to it, and it stays the same. Okay, so no solution looks like this, where you get a statement, this is not true. This is simply not true. 0 does not equal 1. Okay, 12 does not equal 11. This is not true. Okay, there's one more possibility. You could end up with infinite solutions. That's the opposite of no solutions. No solutions means there's no number that will work. And infinite solutions means any number will work. Let's take a look. Something like this. If I take a number and I add 3 to it, it's equal to, if I take that same number and I add 3 to it. Well, yeah, that makes sense, right? That's just, you can sort of look at that and be like, oh yeah, that makes sense. It doesn't matter what the number is. If I take it and I add 3 and I just take it and I add 3, I'm going to end up with the same thing. Or you could sort of formally solve it and say, oh, I have x's on both sides. Let me get rid of these x's. And I get 3 equals 3. Okay, now up here, right, I had 0 equals 1. That was not true. 3 equals 3, this is always true. So x could be anything. X could be literally any number. You could put in a 5 here. That would be 8 equals 8. Or you could put in a negative 100 here. Then that would be negative 97 equals negative 97, right? This is always true, and we write infinite solutions. You could put in a decimal there. You could put in a negative number, a positive number, a big number, a small number. Okay, and then let's just look at another one. Okay, I notice over here there's no like terms. There's nothing to do over here, but there's some work to do over here. I'm going to distribute. Then I'm going to combine like terms. And you might already notice that both sides are the same, right? So it's like, okay, if I take a number and I multiply by 3 and I add 12, I'm going to get the same if I take that same number and multiply by 3 and add 12 over here. But formally, I could say, okay, I'm going to solve the equation. Let me get these variables off both sides. And I get 12 equals 12. Well, that is always true. 12 is always equal to 12. And so again, I have x could be, remember x, the solution is the value of the variable that makes the equation true. I could input anything here for x and it would make the equation true.